To understand probability, you need to understand events and how they fit together. Everything we're going to say in this video applies equally well to sets. Events are sets of outcomes within a sample space, but sets are a more general concept, any collection of objects. What we're going to say about events in this video also applies to sets. So anytime you see the word event, you might think in your mind, replace it with the word set, and it should make perfect sense. Okay, first of all, the empty event. This is an event that contains no outcomes. Since it contains no outcomes, its probability is 0. We use that symbol, the circle with the line through it, to represent that particular event, the empty event. Now, the complement of an event is written as, if the event is event A, the complement is written as A with a superscript of C, or A with a little apostrophe or prime next to it, or as not A. Those are 3 different ways to write the complement of an event. This is the set of all outcomes in the sample space that are not in that event. So here we've drawn a little Venn diagram. We have the sample space, which is the rectangle, and everything inside that rectangle that represents the outcomes that are in the sample space. Then we have the event A, which is this circle, and anything in there would be an outcome that is in that event. And then out here, outside the circle but inside the sample space, is where the complement of A resides. Here's an example. We have a number randomly selected from the whole numbers from 1 to 10, and we're going to let event A be that we draw a prime number from this set. So here's our sample space, a set of 10 objects. Here is our event A, which contains the outcomes 2, 3, 5, and 7, which are all the prime numbers in that sample space. And then the complement will be the numbers 1, 4, 6, or the set of numbers 1, 4, 6, 8, 9, and 10. And in this picture, I've drawn the sample space, I put in the event A, and I indicated the 4 outcomes that are in that event. And then out here we have the complement of A with the 6 outcomes that it contains. We're going to use Venn diagrams a lot when we talk about probability. They're a very useful way to illustrate the things we're talking about. Next, we're going to look at the intersection of 2 events. If you have 2 events, A and B, their intersection is written like this: A with a sort of upside down U, and then B, or as A and B. And if you think about that, if you see that, just think A and B whenever you see it. Okay, this is the set of all outcomes in the sample space that are in both A and B. In other words, the intersection of 2 events is the set of outcomes that the 2 events have in common. Here is a Venn diagram that illustrates that. We have the sample space rectangle. We have the circle for event A, the circle for event B. Where they overlap, that is the intersection of the events A and B. And I've shaded that in. Okay, here's a continuation of the previous example. If you let event B be that we draw an even number from our sample space, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that event B would contain the outcomes 2, 4, 6, 8, and 10. And the intersection of A and B would just be 2, because 2 is both a prime number, it's in A, and it's an even number, it's in B, and is the only even prime number. And here's an illustration of that sample space. I have the sample space rectangle. Here's event A and event B. Where they overlap is A and B, or the intersection of A and B, and that contains the number 2. And then out here I have the other 3 values, or the other 3 outcomes that are in event A, 3, 5, and 7. They are in A, but they are not in B. And then I have the 4 other outcomes that are in B, 4, 6, 8, and 10, out here in this part of the B circle. It doesn't overlap with A. So these are values that are in B. They're outcomes that are in B, but they are not in A. So they go out in that part of the circle for B. And then outside the 2 circles, I have the other 2 elements, or 2 outcomes that are in the sample space, 1 and 9. So they lie outside both circles. Now, a very important concept in probability is the concept of disjoint events. We say that disjoint or mutually exclusive if they have no outcomes in common. That is, their intersection is empty. Okay, so this is terminology we're going to use quite a bit. You might see this in different books. Some people use the terminology disjoint, others use mutually exclusive, but they mean the same thing. It means that if an outcome is in one event, it is not in the other. Okay, no outcome can be in both at the same time. They have no outcomes in common. Okay, so their intersection is empty. Here's an example. We have event C where we draw a number that is greater than 7 from our sample space from before. And that would contain these outcomes 8, 9, and 10. Set A, which is the prime numbers, or event A, which contains the prime numbers, and event C, which contains these three numbers, are disjoint events because there are no numbers in the sample space that are both prime and greater than 7. Okay? If we look back at events A and B from before, those are not disjoint because they had 2 in common, and their intersection was not empty. Okay, here are events A and C inside the sample space rectangle. Event A is this circle which contains 2, 3, 5, and 7. Event C is this circle which contains 8, 9, and 10. And then we have the 3 other values, 1, 4, and 6, which are in neither of those events. Finally, the union of 2 events, A and B, which we write like this, A with this sort of U-shaped symbol, B, or as A or B. They mean the same thing. This is a set of all outcomes in the sample space that are in A or B or both. Okay, this is an inclusive kind of or. An outcome is in the union of 2 events if the outcome is in at least one of the events. Here's an illustration of a union. We have our sample space rectangle. We have our circle for event A. We have our circle for event B. And the union of A and B is everything that is inside at least one of these circles, including this part here, which is in both of them. Okay, so any outcome that is in the A circle or the B circle or both is in the union of A and B. Now looking at this in terms of like specific outcomes, we have A union B. This contains the prime numbers, 2, 3, 5, and 7, and it contains the even numbers, 2, 4, 6, 8, 10. So this is the set that represents that particular event. Contains 2, 3, 4, 5, 6, 7, 8, and 10. Not 1, not 9, but everything else, okay, in the sample space. And then we have event A union C, or A or C. That contains the 4 prime numbers, 2, 3, 5, and 7, plus the 3 numbers that are greater than 7, 8, 9, and 10. And that contains 7 objects, or 7 outcomes. And then the union of B and C would consist of the even numbers and the numbers that are greater than 7. So we have 2, 4, 6, 8, and then 9, and then 10. So we have the 5 even numbers. We have the 3 numbers that are in set C greater than 7. And so that adds up to 6 entries. We're going to look at these examples later on when we look at some more probability rules.